Good morning. Today we're going to be starting to work on proportions. Now, what I want to do today is define what a proportion is and then show you how to solve proportions using the three-step method. Definition. A proportion is two equal ratios. A proportion can be written using colon notation like A is to B as C is to D. Here's an example with actual numbers. 7 is to 39 as 28 is to 156. Now, you want to make sure that these are two equal fractions. To solve proportions, you use the cross product property, and this is also a way for you to verify if your answers are correct by making sure that the proportions are equal. And basically you take the bottom of one ratio, multiply it with its opposite ratio. The answer goes with the top number, just like we would do when we were doing fractions. And then we would take 39 and then 28 on the other side and multiply it to check it as well. So basically, multiply the bottom number of one ratio with the top number of the other ratio to get the cross product. And you want to put that product with the top number. You want to do that with the other side. And be sure to put that answer with the top number. So since I get 1092 with this cross product, the 7 and the 156, and then I get 1092 with the cross product of 39 and 28, this is a true proportion. So you can always check your proportions that way. Now, as in rates, you should use the three-step method to solve proportions. And let's review that three-step method that we talked about when we were talking about rates last time. Number one, first you set up your proportion with the known ratios that are given to you in the problem. Then you're going to look crossways and multiply wherever you have two real numbers. The third step is to divide by the product in step 2 with the number that's left over. And remember, the shortcut is set it up, cross multiply, divide. Here's an example. In this example, we're going to solve for x, or the unknown. So you want to set up your proportion first. We have 5 is to 3 as 35 is to I don't know, or my x. Where there are two real numbers, we're going to look crossways, and we're going to multiply, and that's going to be the 3 and the 35. So when we multiply 3 and 35, we get 105. Now that I've used the 3 and the 35, and I'm looking for the unknown, I need to divide this product by the number left over, which is 5. So 5 goes into 105 21 times. Your x is 21. Now the way to check this is to go 3 times 35 we know is 105. And if I put 21 times 5, I get 105. And that's how you can verify that your answer is correct and you have two equal ratios. Here's another example. We're going to solve for y. The setup in this proportion was given 7.8 over y is equal to 6 over 11. When we look crossways for step 2, we're going to get 7.8 times 11. And when we do that, we get 85.8. Now, I'm looking at this proportion. I've used 7.8 and 11. I need to use the 6 to divide into this product in step 3. So 6 goes into 85.8, 14.3 times And remember, all you need to do is take the 14.3 times it by 6 and make sure that it's 85.8 to check the answer. So I always love word problems, and you can spot a proportion word problem right away. You have to look for 3 things that are given, and you're going to be looking for an unknown. And the things that are given are going to be equal in some form. So I call these yum yums, give me somes, because they're word problems, so that you don't have a bad attitude about them. Now here's a word problem that we're going to solve. Mike constructs a scale model of a building. He says that 3/4 feet of height on the real building equals 1/5 inches of the height on the model. So it's just like blueprint reading. If the model is 5 inches tall, how tall is the actual building in feet? So let's go ahead and set this up. We know that the model is 5 inches tall, and we want to know how tall the actual building is in feet based on the ratio that was given. Now let's set up the ratio. Remember, you want to put the same unit on the same row to keep it proportional. So what was given was that 3/4 foot is equivalent to 1 1/5 inches on the model. So the model is the inches, the feet are the actual building. We're trying to find the actual feet for something that is 5 inches in the model. This is my setup. Same unit on the same row. We know that they're proportionate because they gave us a ratio. Now, in step 2, cross multiply where you have 2 real numbers, just like we were doing before. So when I look crossways here, I have 2 real numbers when I take 3/4 foot and multiply it by the 5 inches. So let's do that. And that is going to give me 15/4. And I'm going to keep this improper because I'm still working with it. So in step 3, I take 15/4 and I'm going to divide it by 1/5, which is what is left over. Now remember, when you're multiplying and dividing fractions, you have to first of all make sure that you have improper fractions for any mixed numbers or whole numbers. So that's why we kept this improper. And then you have to use the method of keep, switch, and flip. So we're going to keep the first fraction, 15/4. We're going to change the operation from division to multiplication. And then we're going to flip, or basically use the inverse of 1/5 and make it 5/1. Keep, switch, flip. Now once we've done that, we get 75/4. And when we actually divide 4 into 75, we get 18.75 in a decimal form, or you can write it in fractional form, which is 18 3/4 feet. So if you like decimal form, you can say 18.75 feet. If you like the fractional form, you can write 18 3/4 feet. They're both correct because they both have the same value. You can plug this in to the original proportion, and you should get 15/4 when you do that to check it. In a word problem, don't forget to write the units to the unknown that you're trying to find. That's another way to prove that you've solved the problem, okay? All right, let's do some GED examples. Candy got 4 hits and 8 bats. Jason got 3 hits and 6 bats. The coach says their batting ratios are the same. Which expression shows that they are the same? So you've got 2 ratios here, 4 to 8, 3 to 6. And remember that a true proportion has two equal ratios. So I would set these up and then check them with the cross products. So this one says 4 to 6, but that wasn't what was in our problem, right? We had 4 to 8, 3 to 6, and the top should be hits and bats. So I'm thinking number 2 is more accurate because 3 doesn't even have the right ratio either, and neither does number 4 or number 5. So it would be a choice between 1 and 2, and 2's got the correct ratios in it. So I would pick number 2. We read to understand the question, 4 to 8, 3 to 6. We have to use that strategy of solving word problems. We focus on the question, which expression shows that they are the same. And you can even check this. 8 times 3 is 24, and 6 times 4 is 24. So this is the same. Here you have 18 and 32, so you can really eliminate these by just doing the cross products. When you gather the needed information, we already talked about that it was 4 to 8 and 3 to 6. Plan is to cross multiply, and we already solved it by taking the cross products and checking it. Now, I don't know on the GED if you have this much time to actually go through it, but if you can quickly eliminate using the elimination method that we did here and solve the problem, sometimes you may not be able to check it. So the things that I want you to remember about proportions as you're working on your study guide is that a proportion is two equal ratios. A proportion can be written in fractional or colon form. Simplify your ratios to lowest terms at the end of solving them. You're going to want to use them as improper fractions if you're still calculating your multiplication or division. Proportions can be solved with the three-step method. Actually, I prefer that method because it helps you organize your thoughts and it gives you an automatic plan. Use proportions to solve real-life problems. And so what I'd like you to do is go ahead to your study guide, start working on the proportions, and then let me know if you have any questions. Thanks.